Most of the time, when we develop software, we do it to automate a business process that exists in the real world or to provide solutions to real business problems. The subject area to which the software is being built for is what we call the domain of the software. As example domains, we could have an airline booking domain, banking, e-commerce, oil and gas, to name a few. In order to create software that is valuable for users, the development team must get familiar with the body of knowledge related with the activities that the users perform in the context of each domain. If we start working in a project in any of these domains with a relatively high degree of complexity, we can't just sit down and start coding. Instead, we should focus on the domain that the software is operating in, and we need to create an abstraction of the domain. We learn a lot about a domain while talking with the domain experts, but this raw knowledge is not going to be easily transformed into software constructs unless we build an abstraction of it. This abstraction is a model of the domain. The model is our internal representation of the target domain, and it is very necessary throughout the design and the development process. The domain modeling should be closely related with the software constructs and code design. The model should be created with an eye open to the software and design considerations. Developers should be included as much as possible in the modeling process. The main idea is to choose a model which can be appropriately expressed in software so that the design process is straightforward and based on the model. This is referred to as model-driven design in DDD literature, but we will not further refer to it in this course. We have to consider that a specific domain could be too big and complex to model. We need to be very careful with this. It may be necessary to divide it up in smaller pieces, to group those pieces into logical modules, and take one at a time in order to deal with it. We could even need to leave some parts of the domain out and to find out what is relevant and what is not necessary. This is a challenge by itself, and we will refer to this in Module 3 of this course. We also need to communicate this model with domain experts, with other designers, and with developers. The model is the essence of the software, but we need to create ways to express it, to communicate it with others. We are not alone in this process, so we need to share knowledge and information, and we need to do it well, precisely, completely, and without ambiguity. There are different ways to do that. One is graphical, diagrams, use cases, drawings, pictures, etc. Another is writing. We write down our vision about the domain. Another is language. We can and we should create a language to communicate specific issues about the domain. Once we have a model expressed, we can start doing code design, which means working on the details as opposed to software design, which is about the big picture. Code design is also very important, but not as fundamental as software design. Nonetheless, the final product won't be good without good code design. Here, code design patterns come handy, and they should be applied when necessary, as well as solid principles. Good coding techniques help to create clean and maintainable code. There are different approaches to software design. One is the waterfall design method, which, roughly speaking, involves creating a lot of software design upfront, delaying the cycle time substantially. This has several drawbacks, as we all know. Another approach is the one which is related with agile methodologies, which employ a great deal of implementation flexibility and, through iterative development with continuous business stakeholder participation and a lot of refactoring, the development team gets to learn more about the customer domain and can better produce software that meets the customer needs. So, to start wrapping up the idea, domain-driven design combines design and development practice and shows how design and development can work together to create a better solution. Good design will accelerate the development, while feedback coming from the development process will enhance the design.